We start with kernel type, which is monolithic kernel. Is used in BSD Linux as the kernel type. Monolithic kernel means the entire operating system working in kernel space and also alone in supervisor mode. Monolithic model differs from other operating system architecture such as microkernel architecture in that it alone defines a high-level virtual interface over computer hardware. Most modern monolithic operating systems such as OpenVMS, BSD, Linux, and other in addition to Multics can dynamically load and unload executable module. Now let's move to the next one, which is system program. A program is a set of instructions that tell the computer to do various things. This section gives an overview of two main ways in which you can give this instruction or command as they are usually called. Uses an interpreter and the other use a compiler. Here is the interpreter that available with BSD: Basic, Libs, Perl, Scheme, Icon, Logo, Python, Ruby, TRC, and TK. First of all, you write code in a file or files using an editor. Then you run the compiler and see if it accepts your program. If it did compile and give you a program, you can write it either at a shell command from or in a debugger to see if it works properly. Okay, now let's continue with system boot. FreeBSD boot process provides a great deal of flexibility in customizing what happens when the system starts, including the ability to select from different OS installed on the same computers, different version of the same operating system, or different installed kernel. Remainder of the FreeBSD bootstrap system is divided into 3 stages. The last one is dtrace. Dtrace is used to diagnose performance problems and also can be used to help investigate and debug unexpected behavior in both the FreeBSD kernel and in userland program.
So, for the introduction, FreeBSD is assigned a scheduling priority that determines in which run queue they are placed. In selecting a new thread to run, the system can run queue from highest to lowest priority. If multiple threads decide on a queue, the system runs the round robin with equal to amount of time allowed. Okay, if a thread block, it is not put back onto any run queue, but if a thread used up, the time quantum is allowed. It is placed at the end of the queue from which it came, and the thread at the front of the queue is selected its run. For the time shared thread scheduling is in FreeBSD is based on multi-level feedback queue. So I can explain about multi-level after this. So the system adjusts the priority of the thread dynamically to reflect resources requirement. Example being block awaiting an event. Amount of resources consumed by a thread. Example CPU time. Threads are moved between run queue based on change in scheduling priority. When running thread attain a higher priority, the system switch to immediately. Otherwise, time system switch to the higher priority thread as soon as the current thread exits the kernel. System tells this short-term scheduling that are blocked waiting for input and output for 1 or more seconds by lowering the priority at thread amount of CPU times. So, this new processing burst ready queue for CPU execution. Process enter in Q1 is highest priority also allocate the shortened burst of CPU to process, example 60 milliseconds. And after that, quantum 2 keep ending 60 milliseconds to each of the next quantum. Q1 complete the 8 burst must wait Q to exit the system. When Q1 not complete, fall down to Q2, but Q2 receive when Q1 empty the processing time. Q3 receive when both are termed Q1 and Q2 as inti. Q5 is lowest priority because Q5 at level lastly receive when all highest priority is inti, because Q5 do not receive when process is the workload is high. In this process is allocate to queue on a non-interrupt basis for normal processing. Interrupt as critical. Service can interrupt current processing.
So now I will explain a little bit for process synchronization in BSD Linux. Actually, Linux have two synchronization, that are kernel synchronization and process synchronization, but we will focusing on process synchronization. In process synchronization, they are using many type of commands such as signal, semaphore and pipes. So these are the example of signal command used in BSD Linux. As you can see, there are signal thread, signal kill, signal alarm and signal burst there.
What is deadlock? So deadlock occur when process A acquire resources resources 1 and is waiting for resources 2. Meanwhile, process B acquire resources 2 and is waiting for resources 1. That means both processes are waiting for another resources and holding one resources. So both of them are waiting. So it occur a deadlock. There are 4 conditions for deadlock to exist. 1. Mutual exclusion. 2. Hold and wait. 3. No preemption. And 4. Circular wait. All four conditions must hold for a deadlock to occur. Deadlock prevention must negate one of necessary condition, which is 1. Mutual exclusion. Mutual exclusion must make resources shareable without locks, which is not always possible with printer, pin memory or DMA. Okay. Number 2. Hold and wait. Do not hold resources when waiting for another request or resources before beginning execution. Processes do not know what resources they will need ahead of time. So, this hold and wait condition has 2 problems, which is starvation, the process is waiting on many popular resource, and low utilization, which is need resource only for a bit. And the last condition is circular wait. We have to impose partial ordering in resources, which is we request them in order to avoid to make prevention on the law.
For the last part is the file and directory structure for this BSD operating system. The file structure contains of few basics type of its data structures such as bootstrap and volume descriptors that I will explain later on the next slide. Also containing number 2 is a file descriptors, which is an information that describes a file. For an example, its ownership, its protection, and its time of last update. The fourth is free space descriptors that lists of blocks of unused space that can be allocated to the files. The last part is a file name descriptors. Is a data structures that associate user chosen names with the file. This is an example of what a directory means in a BSD operating system. The bin /usr/boot/root and /sbin. The /root is known as a home directory for the root account. The boot directory is for programs and configuration files during operating system boot.